Continuing our study of 3.3, I have example 5 here. We're going to find the relative extrema of this function. Now before, in the last example, it said to find the extreme values. That's when we're talking about y values. If you want to know where they occur, that's the x values. So make sure that you understand what the question is asking before you try to do it. Okay, so this one, find the relative extrema, so we have to take the derivative. 2/3 x squared minus 4 to the negative 1/3 times 2x. Don't forget the chain rule there. All right, this looks pretty bad, so let's try to make it better. F prime of x, that would be 4x, 3 on the bottom, negative 1/3 power is cube root, x squared minus 4. If we're trying to find the critical values, we got to figure out where the derivative is 0 or undefined. So that would be at 0 for the numerator, and then also positive or negative 2. Okay, so put those on our number line. These are our x values, and we're testing f prime. All right, so you can plug in numbers on your own, or I can just tell you, and you can hopefully trust me. Negative, positive, negative, positive. So we're asking, find the relative extrema. So we need to plug in those values. So let's see, f of negative 2. If we plug that in, negative 2 would be 4 minus 4, that's 0. Okay. F of 2 is also going to be 0. And we have f of 0, that'll be negative 4 to the 2/3 power. Oops. Okay, so we need to answer the question and we need to justify. So we have f has a relative max of 4 to the 2/3 power. I know it had a negative earlier, but it would really be like that. Sorry. So if you square it, ends up being positive. So x has a relative max of 4 to the 2/3. And since f prime goes from positive to negative there, and f has a relative min of 0 at x equals 2 and x equals negative 2, since f prime goes from negative to positive at those values. All right, so I'm going to try not to write as much just because the pen isn't working out too well. So you really have to listen and then ask questions if you don't understand something. All right, so let's hope for a skinnier pen will make a difference. I don't know. Find the x-coordinates of the relative extrema. So this time we don't care what the extreme values are, we just want to know where they occur. So we need to take the derivative, t prime of k, and that is k to the 2/3 power times tk minus 1. So actually, before I take the derivative, I think I'm going to simplify that. So that would be 2k, I hate the way this is writing. So it'd be 2k, 2 times k to the 5/3, because it'd be 2/3 plus, oh gosh, 2/3 plus 1. There we go. Minus k to the 2/3. And that's equal to t of k. I just simplified it. I didn't take the derivative yet. Okay, now that it looks like that, now I'll take the derivative. T prime of k would be 10/3 k to the 2/3 minus 2/3 k to the negative 1/3. It might be hard to find critical values that way, so I'm going to factor least powers out. Okay, so I'm going to take out a 2/3 k to the negative 1/3. So if I do that, 2/3 times what gives you 10/3? So that would be 5. And then k, if we have negative 1/3 and we're trying to get 2/3, that would just be k to the 1 minus 1, because we have 2/3 k to the negative 1/3. All right, so we have two critical values. We'll see if either of them have a min or max. The first one is 0. The second one is 1/5. We're testing k values, and we want to check the signs of t prime. So if you plug in some values, we're going to get plus, minus, plus. So then that tells us that I'm going to write it and then I'll erase it so we could do part B. All right, t has a relative max at x equals 0 since t prime changes from positive to negative at t equals 0, or at x equals 0. I guess instead of x, it really should say k. K, there we go. Ooh, all right, let's make that look better. K equals 0. All right, that's the first part. And then the second part would be t has a relative minimum. All right, this is the second part. T has a relative minimum at k equals 1/5 since t prime changes from negative to positive at k equals 1/5. All right, and again, we didn't care what the relative extreme values are, we just needed the x values. All right, so let's clear that and try the next one. So we have j of k this time. It's similar, so I'm going to expand it first before I take the derivative. J of k equals 2k to the 4/3 minus k to the 1/3. All right, take the derivative j prime of k, 8/3 k to the 1/3 power minus 1/3 k to the negative 2/3. To make this look good, we're going to factor least powers. Let's take out a 1/3 k to the negative 2/3. Okay, so we get 8k minus 1. That gives us two critical values we need to check. We're going to check 0 and we're going to check 1/8. Those are k values, and we're checking j prime for the signs. If you do that, you should get positive, negative, positive. The numbers I plugged in were -1, 1/16, and 1. Okay, so then it appears that j has a relative maximum at k equals 0, and that is because j prime changed from positive to negative. And then j has a relative minimum value at k equals 1/8, and that's because j prime changes from negative to positive there. All right, so let's keep going. Clear some of that out. I don't like seeing that. All right. Now, when you have piecewise functions, it really helps to graph it or get a good idea of what the picture looks like, because that can make all the difference. So we have, looks like a linear equation, x plus 3, except for we have a hole at x equals 1. Now, x equals 1, we do have a point. At x equals 1, y equals 2. So it's going to be somewhere down there. All right, so if you look at the graph, we don't have to take a derivative, we can just look. And so f has a relative minimum value of 2 at x equals 1. And this time, to justify it, Since there are, we could say since there are no lower values immediately to the left or the right. Sorry, lower values to the left or to the right of that. So we're not justifying it with the first derivative test, we're just looking at the graph. Okay, and we can do something similar with this first function if you know what it looks like. Okay, so now I see that this is a fraction, so I'm going to note, it says note there, note that x cannot equal 0. So let's rearrange this function a little. If I factor out an x, whoa, not what I meant to do. We'll see that there's a hole occurring at x equals 0, and then it's just the graph of x squared plus 1. We have a hole at x equals 0, but it's just this nice looking parabola. So we need to first determine the intervals of increasing and decreasing, and then any x coordinates of relative extrema. So f is decreasing on the interval from negative infinity all the way up to 0. F is increasing from 0 to infinity. And then to answer the bottom part, there are no relative extreme values. We would have 1 at x equals 0 if it were a point, but we don't have any point there, so we can't have it. Okay, we're going to do something similar here. We're going to note that x cannot equal 0. We can't factor it out and make it look as nice as we did before, but I can rearrange it. So if I wrote this, x to the fourth over x squared, that's x squared, and then that's x to the negative 2. Okay, let's take the derivative. Since you probably and I probably don't really know the graph too easily without doing some work, so we're going to just try the first derivative test here. So we get negative 2x plus 2x to the negative 3. I'm going to factor least powers. Take a 2x to the negative 3. So we're going to get negative x to the fourth, because we need x to the 1, plus 1. All right, if I rearrange this equation, I could put 1 minus x to the fourth all over x cubed. All right, to figure out where that might possibly, the derivative might change signs. The critical values would be at 1 and negative 1. And remember that the 0 we're going to include because it was not included in the domain, so the signs could change there. All right, so negative 1, 0, 1. I like to put a hole there just to remind myself that that's not going to be a relative extreme value, f prime. If we test these signs, it ends up being positive, negative, positive, negative. So it does change signs. F prime does change signs at 0, but it's not an extreme value. Remember, because it wasn't part of the domain. All right, so now we just need to answer the question. F is increasing on the intervals from negative infinity all the way to negative 1, and also from 0 to 1. F is decreasing from negative 1 to 0, and also from 1 to infinity. F has a relative max at x equals negative 1 and x equals 1. And the reason why is because f prime changes from positive to negative there, and there are no relative mins. Okay, so that concludes section 3.3.